Hey, if you're here watching this video, that means you finished the 2 tests for today. Good job. I wanted to do this video to give you a quick introduction to the next unit, which is chemical reactions and the idea of conservation of mass. So let's take a quick look at this chemical equation, which you're probably already kind of familiar with in a certain way, and we're going to talk about the equation itself and what the law of conservation of mass kind of means. So let me flip the camera. Okay, so here we've got, hopefully you can see it okay, the chemical formula for baking soda and vinegar. Okay, there's more stuff over here because we always think about putting baking soda and vinegar together, but we often don't really think about what the result of that is. So whatever we put into a chemical reaction is called our reactants, and whatever we get out is called our products. So let's take a little bit of a closer look. So baking soda, its chemical name, its chemical formula, is NaHCO3, sodium bicarbonate is kind of really what that is. And then vinegar is really called acetic acid, but that's CH3COOH. So basically we've got some sodium, we've got some hydrogen, we've got some carbons and oxygens, and this one is all carbons and oxygens and hydrogens. Okay, now when we go through to the other side, that arrow means that a reaction has happened. So you put those two things together, a reaction happens, and then you get these things. So we've talked about how we get carbon dioxide gas. That's what the bubbles are. We also get some water, and we also get this stuff called sodium acetate. If you've ever had salt and vinegar potato chips, that is the main flavoring in salt and vinegar potato chips. It's also commonly used as like a food preservative. It's kind of acidic and bacteria don't like it. So that's actually kind of a useful chemical that you've probably actually eaten or consumed in your life. So this stuff that's left over, you could drink it. It's kind of acidic. I wouldn't really recommend it. But you could consume the products of the baking soda and vinegar reaction. It wouldn't kill you. Might not taste very good though. So anyway, sodium acetate's chemical formula is this. Water, you probably know as H2O, and carbon dioxide gas, easy enough, CO2, right? Again, over here, we just have a sodium and a bunch of carbons, hydrogens, and oxygens, right? Real quick, let's take a look at this. This is a list of what elements we have going on in our formula on each side. So this is the products, this is what we start with, and this is what we end with. We start with 1 sodium and end with 1 sodium. We start with 5 hydrogens and end with 5 hydrogens. Start with 3 carbons, end with 3 carbons, start with 5 oxygens, end with 5 oxygens. This is really important. This is called the law of conservation of mass, and it basically says that whatever you start with, you have to end with. You can't just make more sodiums out of thin air. You can't just make more anything out of thin air. Whatever atoms you start with, you have to end with. And you also can't just make them disappear. You can't start with more than you end with. It's got to go somewhere. Okay, so that's called the law of conservation of mass. We're going to look more closely at that, but that just shows you that this table right down here kind of summarizes what we start with and what we end with. Now I want to prove this to you in a certain way. So I have over here on a desk over behind the camera, which we'll go to in a minute, I measured out 8.3 grams of baking soda and 46.6 grams of vinegar. I'm going to put them in a bottle. The bottle happens to weigh 437.6 grams, and I'm going to seal up the bottle. I chose a bottle that is resistant to pressure. It shouldn't make too much pressure. You could do this in like a pop bottle or something too, but I just used the bottle that I had. And I'm going to predict that in the end, once we do the reaction, the bottle and the stuff inside it will have a mass of 492.5 grams. That will prove that whatever we start with, we also end with. We started with a certain amount of baking soda and vinegar in the bottle, and although our products are different things, they're still going to have the same mass altogether. So we rearranged the atoms that we started with, but they're all still there. So let's go ahead and do that reaction. Okay, so here's my baking soda already in the bottle. Here's my vinegar. Here's my pressure bottle, and hopefully I'll be able to put this all together and cap it up before it explodes in my face and all over the room. Let's give it a shot. If it doesn't, it'll be funny anyway, right? Here we go. All right, I think I got most of it in there. Obviously, you can see the reaction proceeding. It's all bubbly. There's probably pressure building in this bottle. In fact, I noticed I put this lid down just with my fingers at first, and then there's a little locking clip. I didn't quite get the clip down, and it went psst. So there's some pressure in there for sure. So the reaction happened. Let's take the mass. I've got a digital scale here. Let's grab this, shove it to you. Turn it on, make sure you can read it. Now my prediction was 492.5 grams. Let's see how close we get. 491.7, 491.8. Not too bad. I may have lost a little bit of carbon dioxide gas coming out. Also, I mean, that's a decent amount of weight. That's half a kilogram. And so my scale may not be totally accurate. Point here, guys, is we're going to be learning about the law of conservation of mass. How whatever you start with in a chemical reaction, you have to end with. We're going to look a little bit more closely at chemical formulas just so that you see a couple and are familiar with what they look like and kind of how to read them. We won't go too far in depth with it just because we don't have the time, but hopefully this has been a little bit of an introduction for you. Good job completing the tests. Look at the class wrap up to see what you got to do next.